this. Okay, you can start.
All right. So welcome everybody, and thanks for taking a little time out of your Friday to come to this presentation. And the reason I suggested this topic with Lev was I find it that there's a need for just base level understanding of Git when in the development community. I'm often surprised how little is understood and known about version control, let alone Git itself. So I suggested this as a topic so that people on this call could have access to some base level information and understanding of Git, as well as anyone who runs across this video. So topic title is Git distributed version control. Who am I? I'm Chris von Rabenau. I'm a cloud architect at Redapt. I've been working with version control systems for quite a number of years. In 2018, I was introduced to a person who changed my life. I will have to say, changed my life for the good. Paul Kennedy was a coworker in a previous organization that I worked in, and he will come up a number of times. And during this presentation, he taught me how to actually use Git and leverage it in my day-to-day use. And up to that point, it had been kind of a, wow, I didn't really understand it. I understood sort of what it did, but didn't really have any control over it. Now I understand it and use it and leverage it. Here's a little bit of contact information for me. Feel free to email me, and there's my LinkedIn page. And then we'll talk about Git remotes. This is my GitHub remote is CGAPRI. So feel free to poke me there too. So first, we have to understand what is version control before we can actually talk about why and the different types of version control. The concept behind version control is to be able to see what changed and if we take just a microcosm example of a file, what changed in this file since the last time it was saved? That's one of the things that version control tracks. The other thing it does, it allows you to manage those changes. So can I revert if I want to, or can I control where I'm working from? And then the third aspect to that is over time. So can I see those changes over time? Can I manage those changes over time? So these are the ways that what version control gives you is power to decide where it is that your work comes from or where it's going, right? So why then do we want to use version control? Well, we've talked about it provides a mechanism for managing and tracking changes. So can I manage the changes? Can I roll back? Can I track where I was? Can I see where in the code X happened? But then it also gives you an easy way to revert to previous versions of the code. So I've been working all week. I've got this great thing in place. And next week I come and I start working again on my file and I completely trash it. Can I get back to that great state that I had last week? So that's one of the things, another thing that version control gives us, the ability to revert. It also provides a mechanism for faster development. If I can build off of code in a different place, so say I want to start working from that code from last week, but I also want to keep the code that I've done this week, this is one of the things that version control allows you to do. It also gives you the ability for easier collaboration with other people. So I can work on my code, you can work on your code, and we've got a mechanism then to collaborate on that code. And another really powerful aspect of version control is understanding the history of your code. With a good version control system, you can go back and you can look and see when did this change? That's what changed here. That's why it's not working. Or, and there's a function in Git, and I'll touch on that, is who did this change? Who did the change that's happening right here? Because you might, and not necessarily because you want to go and take them to the woodshed for it. Maybe you want to go and understand what they were doing when that change happened, right? And then lastly, when you have a version control system, you've got a backup mechanism, because however it's set up, you've got a place that you've got a way to back up your code either remotely or in another repository somewhere in your environments. So these are kind of the top level concepts behind version control. So a little short history on version control. So back in the 70s, and I always smirk when I see or hear the term Bell Labs. There are so many things in compute history that started in Bell Labs. And this Bell Labs is one of the places that version control started by tracking the changes to files. But at that point, it was only one person could work on a file, only one person could check out a file, and the whole file was tracked. So any changes, it was the whole file. But the concept of tracking deltas started there, the changes to the file. And then in the 80s, RCS came about and it started tracking just the deltas. So what changed in a file? And this was a local version control system. So it was, here's on my environment, I've made these changes. What has changed on this in these files? Not changing the whole file, but changes in that file. And then CVS came along, and CVS was a client server model. And we'll talk about that a little bit. And in a client server model, you've got data stored in a server, and you check out the files and you review, and you've got access to the changes. And then in 2000, SVN came out, and it was kind of a step up from CVS. With SVN, now multiple people could work in a project and they could collaborate a little bit easier in this server model. But and the CVS model, how that worked is you checked out code. So here I am, I check out code and I work on that code, and then no one can work on that code until I check it back in. The big crisis that you would run into with this, and I experienced this myself on a number of occasions. So Lev, he's working on code, he's checked out 3 or 4 chunks of code, and then Lev goes on vacation. No one else can work on those files because Lev hasn't checked those files back in. Yeah, there was administrative mechanisms for fixing that, but it was a nightmare. SVN gave us a little more flexibility in that process. With a centralized version control system, you could identify where the changes were happening, and you had abilities to resolve those conflicts, and that was great. And then came along the concept that the Linux project was working with BitKeeper, and BitKeeper was a similar product to this, and there was a licensing issue, and somebody in the Linux project was trying to reverse engineer the software, and there became this huge battle over it, and finally I'm getting ahead of myself. Let me stop here. So this is what local version control looks like. So I've got a file and I've got a version database. So I'm tracking the versions. So I've got version 1 and then version 2 and version 3 of this files on my local computer. So I know, and my local machine knows where this version is. You see this when you're using Microsoft Word and tracking changes in Microsoft, and you can roll back in Microsoft Word to different versions. That's a local version control. Now with Office 365, it's up in the cloud, so one could argue that it's more of a server-based, but it's the same sort of thing. So what is the version of this file right here? So if we take that then to the centralized version control server mechanism, computer A checks out a file, they work on that file, they check it back in. And then computer B can check that file out and check it back in. With SVN, which was a step forward with this, computer A could work on the same file as computer B. And when they would check that file in, then you would resolve the conflicts at the server level on the server, right? So that's centralized version control. Well, that's all fine and good, except that what if the server goes offline or your server gets corrupted, or there are various different reasons why this doesn't work, which led to Git. And my friend Paul, this is I actually gave Paul this image once because he has this statement: Git means never having to say you're sorry. And if you're using Git correctly, you don't. You can almost always recover from Git. The only time you really can't recover when you're using Git is when you failed to commit your work. So I have gotten myself in some pretty hairy worlds with my code. And at times it required me calling Paul up and saying, hey, Paul, can you help me walk through this? We've almost always been able to recover myself from where I was. The only time I couldn't recover was when I hadn't done the commits that I thought I had done. So, ta-da, Git. So what is Git? It's a distributed version control system, which means all the files and history come with the repository. When I check out, when I clone a repository, I get the entire history of that repository. And there's no centralized repository of it. And there's no checkout strategy. So I don't have to check out my files. I get a full mirror of what's in the repository, and I can work in that repository. The value of what the distributed part comes into play is when I want to share that work, others can actually grab that work and work with it. The little side note about Linus Torvalds. So the conversation I was alluding to about BitKeeper and this whole tension is finally he went home and he just like rewrote. He said, I'm going to write a solution for this, and apparently it took him 10 days. And there's a really interesting interview asking him various different things about it, and like how to get its name. Well, Git is kind of like it's a reference to somebody who's not desirable. And there was a conversation. He joked that nobody likes doing version control. Nobody likes him. They just named it Git. But what I thought was the most curious thing about this, they asked him, so you did this in 10 days. How many nights did you work overnight, over midnight? And he said, well, it's all in the Git history. And the question was, it's all in the Git history? And he said, well, okay, so maybe not the first couple of steps of it, but he actually, if you look at the code, the repository, the history of Git in the repository, you can actually see his work as he incrementally built Git by actually using Git to do it. That it's really kind of cool. So we've got a distributed version control system, and what does that look like now? Oops, if we go back, if we look here, and this image is taken right from the Git documentation, and I have an issue with this because it starts to actually create this illusion that people have about GitHub, right? There is no server computer in a distributed version control system. You can all agree on a master location. This is the source of truth, but there isn't necessarily in a Git repository system, in a distributed version control, there isn't necessarily a server computer. There can be a server computer, and that's what like GitHub is, and Bitbucket, and various different things like that. But you can have a local. You can have your repository, your main repository, on your local machine. It doesn't, and you just define that this is your remote. But I can change my remote at any point. I can have a repository that doesn't have a remote. So the concept of actually saying that there's a server computer involved, I like to think that this is actually computer C, because that's exactly how it can work. As long as you all agree that you're putting your code and merging your code together in a certain way, you don't have to have a server computer. That's the point behind distributed version control. But be that as it may, you'll notice that all of these computers have all versions of the code, right? So version 1, 2, 3 on all 3 machines here. And any machine can work on a file and then share that file with the other remotes, the other repositories, right? So, and what comes with this is you can have more conflicts than you do in other version control systems. But one of the beauties of what Git provides is it does a very good job of identifying exactly what has changed and only creates a conflict if that change occurs in the same place as someone else's change. So, and sometimes it's miraculous at how well it manages the different versions of code. So there we go. So what are use cases of a distributed system, version control system? You can do it in a local development. So oftentimes I will have 2 different directories on my machine. One I refer to as my pristine, and then here's the work that here's the experimental code that I'm working on, and my remote, quote unquote remote, is literally another folder on my computer. So you can keep your code in sync. You can do various different code developments in different environments, and still keep it all locally. Then there's the single user development concept where you have like, say you use GitHub, and you're going to store, that's where your main branch, your code, your main repository of your code is. And so then I can use it on this laptop. I can go to my desktop. I can go to a remote station and work on my code and commit code back to myself. And there's no conflicts with my code from somebody else's development because I'm the only one doing it. I know what's going on. And then you can get into the multi-party development where now there's multiple people committing code, and how do we manage that? Oops. Let's go back. And so multi-party development allows the ability to have multiple people working on code, committing those changes, and having systems to control when code gets merged into the main branch, who decides that, etc. And that's one of the cases where the strength and power of interfaces like GitHub or Bitbucket really come into play. They've got a lot of mechanisms for managing those controls on how does code get merged into the main branch, who decides, who has decision-making power, etc. Azure DevOps is another case of that. So general concepts that to cover here before we go diving into the demo and talk about Git and how to use it. One of the things is cloning. So that's how you initiate a copy of a repository. I clone that repository. And that, again, if we think about local, I can clone a Git repository that's a local directory. I can clone that. I can clone a remote repository. And just as a side note, I can fork off of a clone. When I clone a remote repository, what happens is it copies it down. It sets a link to that repository. So when there's code that goes to that remote, I can pull that code. I submit code back to that remote. But if I decide, for example, that I'm working with Yuri, and Yuri and we just can't agree on the direction of code, I can say, you know what, I'm going to fork, and I just take my remote and I point it someplace else. It doesn't go back to the main location of the agreed upon remote. So that's cloning. Branching means I'm going to take code and I'm going to start working. I don't want to mess with what exists in the main branch. I'm going to create a branch and say I'm working on, a mobile feature. And so I create a mobile feature branch, I can do all my work on that mobile feature branch and then merge it back into the main branch when I'm completed with that work. And the beauty of that, and this is where the multi-party development comes into play. Someone else can start working on code somewhere else on main, and it doesn't affect me. I don't really care until I merge my code back in. There's recommendations. You actually bring main back into your code on a regular basis so that you reduce the amount of conflicts and you know what's currently in main, and can leverage any of the positive changes. But I don't have to worry about what's going on anywhere else in the code while I'm working on my branch. And then additionally, I can say, Lev can call me up and say, hey, Chris, I really need you to work on this pronto. Forget what you're working on that mobile branch. I need you to fix this bug. I can check out a new branch and Git will keep the history of what I was doing before and allow me to start working on this bug fix. When the bug fix is finished, I go check out my branch for my mobile development, and ta-da, I've not lost anything, nothing is broken, and I don't have to make any backups of my code anywhere along the way. So that's branching. Staging is, once I have added a file, it's referred to as staging. And that means that file is being tracked by Git, but it's actually not been written to history. So Git knows that the file exists, but unless I actually commit that, it's not part of the repository, either in the branch that I'm working on, right? So if I've got a file and it's being tracked, and I realize that I was still on main when I was supposed to be working on this bug, I can just switch over to that bug branch that I created, and that file is going to come with me because it's just in staging. And then I can commit it to my bug branch rather than having to go, oh, geez, now I got to save this file somehow and move it over to my bug branch. As long as I haven't committed it, it's still in. I can still just hop over to my bug branch because it's in staging. And so that gets us to commit. So once I'm ready for this to actually become part of my code base in my branch, I commit that to the history. And I commit that with a message. And that commit will also say what is being committed, what files are being committed here. I can add detailed information. Typically, your Git message, your commit message is something short and precise about what you've done, but you can have a whole lot more dialogue about what is going on in that commit in your Git in the Git commit history message. So that's what happens when I do that. Then it creates a SHA in the index, a unique SHA in the index that says, here's the pointer for this change. And we'll have a demonstration a little bit later on what we can do with that SHA, why there's value in the SHA. And we'll see that when we're looking at the log. So Git has a log of everything that happens, literally everything that happens in the repository. And there's a local, you've got your local log, and then there's the remote log. So the remote log has information about all the work that's come in and merged into the branch or merged into the main code. Your local log can have different information and will have different information than the remote log. And then lastly, the concept of head. And head is in caps for a reason, because in Git, head is where you're standing. So as my friend Paul says, you're always standing on your head. So when you look at the log, you can see where you are in the code base by looking for the concept of head. And we'll talk a little bit more about head further on in the presentation here. So these are general concepts to understand. And then, come on, click. So first, you got to be prepared to use Git. So I'm not going to go through installing Git. If you don't have Git installed in your machine, there's the link in this will be in this presentation on the Git the Git man pages on how to install Git. There's how to do it on Linux, Windows, Mac, etc. So once we actually have Git installed, though, there are some things that you want to do. You want to set your username. Oops, back slide. You want to set your username so that when you do a commit, it says who it is that did this commit. And if you don't do that, it'll throw you a warning. Same thing if you don't have your user email, it'll throw up a warning every time you do a commit. It says, hey, you haven't done it, you haven't set your username and user email. The purpose behind this is if you've got a code commit, somebody might want to talk to you about it. They might want to say, hey, how did you do this? Or they might want to say, what were you thinking? But when you add your username and email, that gets tagged into your commit so that we know who did this work. And there's a concept called git blame that allows us to see that if we want to. Then this is, whenever I set up Git, I also add this alias. This is a Paul Kennedy alias, and we'll look at Git's log later on. But what this does is it gives a very useful linear view of visual view of the code and of the merges and of the code and where the commits have occurred. That's really useful when you're trying to diagnose where are you, where am I going, what's happening right now in the code base. So that's something I always encourage people to add to their Git config. And then lastly, you can see what's in your Git config by git config -- list. So that's a handy little way to double check and see what's there. Some Git implementations by default give you aliases for things like checkout or things like that. So it's useful to see what actually is in your Git config -- list. So once we have Git prepared, then we can start actually using it. And so this is where I'm going to hop back and forth between terminal so that I can demonstrate some of these things, but I'll explain what we're going to do first. We're going to initiate a repository. We're going to create a branch in that repository, and then we're going to add some files, and we're going to update some files, and we're going to commit those files, those changes. And so we'll see what that looks like. So if I go here and I do a git init, and we'll say Git Demo 2. So what's happened is if we look star, what's happened is it's created a repository Git Demo 2. So if we cd into there and do a git status, we're now on the master branch. There's been no commits. It's an empty commit. It's an empty repository, and that's what this message said here. It created, initialized an empty Git repository. It's my recommendation, and this is again a Paul Kennedy thing, is to make it an empty commit at the very beginning of the repository. And to do that, you say allow empty. Because if you try to do an empty commit, it's going to throw a flag and say, I don't know what you're trying to do here. There's nothing here for me to commit. And the reason we want to do this is if I do a whole bunch of work in my repository and I make a commit and I realize I need to roll back. If you don't have, so we'll demonstrate Git's log. So I now have this empty commit. If I don't have this commit, this initial commit, if I do another commit and I want to roll it back, there's no place for me to go. You can technically roll it back, but it's a lot of work. It's easier just to roll back to the beginning if you actually have that. Oh, look at that, I have misspelling here. So here's we're going to do a git commit -- amend. So I can correct the very last commit with this -- amend. So what that does is it pulls me Let's see if this works. No, okay. Well, I'm not gonna get focused on that right now. So here we are, we're in our master branch. We've created initial commit, and so we're going to, the very next thing was we're going to start development. So we're going to create a branch. So git, so there are two ways to do this. You can say git branch, and we'll say feature one. And if we do a git slog, here we are, we've created feature one. But if we do a git status, and this is why I don't like this method, we do a git status, I am still on branch master, right? So I've created a branch, but I'm on branch master. And what I've seen oftentimes happen is people start developing and they do commits and they do commits, and then they're like, oh, I'm not in the right place. I meant to be on feature one. So I prefer the method of git checkout -b, which says checkout and create a branch feature two. And now if I do git status, I'm on feature two. So that's the benefit of using the checkout -b. Now I have a script. Let's see here. So I've got a script, and all it does is you pass in some variables to it, and it will create a file and make a commit. So we'll not use this just yet because I want to demonstrate how we actually add a file. So if I say touch, so touches, for those of you that don't know the bash command line, touch creates a file. So if we take touch test1.txt, we look here, there's test1.txt has been added to my directory. Now, if we do a git status, it'll say there are untracked files. So these files exist in my file system. Git is not tracking these two files. So what do we do with those? We're going to add those. We're going to add them to the repository. And so there are two ways we can do this. We can do a git add dot, which means git add everything that's in my repository or that's being untracked right now. And so if we do our git status now, we'll see that both of those files are now in the tracking. Now, say they create files, I don't want that being, so I could say git restore staged create files.sh. Now, if I do git status again, you see create files.sh is no longer being tracked, because I didn't really mean to do .all, right? So now the other way to add a single file is we can go git add and call that file, and then it will be put into our staging. So we look at our git status. Now these files are staged, right? So that concept that I was talking about, now Git knows about these files, but they're not actually part of the history yet. So if I do a git checkout feature one, you'll notice that those files come with me, right? If I do a git commit minus, we're going to just do test one here. I'm not going to add a message just yet. So if I do a git commit test one, what that does is it brings up the interface. It's going to ask me for my commit message. And you see my cursor right here at the top. It's ready for me to actually enter a commit message. So adding test1.txt. Now I can add more information down here. And you'll notice here, this is what's being committed, is test1. And it's saying at this point, the untracked files were create files.sh. So there's a lot of information that's being tracked that put into our repository log, the ref log. And so now the file you'll notice that the test.txt doesn't exist as it's not being displayed because now it's committed into the history. And if I then I do my git slog, now here's feature 1, and I added test 1 at that point. So now let's go check out feature 2. And if I do an ls, you'll notice that test1.txt doesn't exist here because that file is now committed on that branch. That's where it is. It's only in feature 1. If I do git checkout master and do an ls, that file still isn't there. But if I check out feature 1, there's my file, right? So now here I am on feature 1. I'm gonna add some, I'm gonna update this file. So I'm adding a line. Now, if I do my git status again, there's been an update to this file. So this file has now been modified. So now I'm going to git commit again. And in this case, I'm going to do AM, which means commit all of the files that are in staging with the message that follows the M. And we're going to say update test 1. And now if we do our git slog, now we're here, we're standing on our head where update test 1 is. Now, curious thing that you can do is I can go back here. So this is our SHA. I didn't bring that up earlier. These numbers here on the side, these hexadecimal numbers, these are the SHA pointers for this location for this commit. So if I copy this commit and check it, I can check it out. It's going to give me a warning. It's going to say I'm in a detached head state. And what that means, if we look at git log, here's my head. I'm standing on my head, but there is no branch associated with this. So it's giving me a warning that, hey, buddy, you might be doing something here, but when you try to commit this, there's no place for me to commit this to. So, but if we look at our test 1, it's empty because there was nothing in that file at this point in our branch. And this is one of the concepts that I think that I've had engineers struggle the most with, is I've seen people do backups of a file in a Git branch. There's no point in it. It's actually redundant, and it's going to cause you more headaches if you make a backup of that file, because Git already knows what its previous state was. The one thing that I would say is there's kind of a general rule is commit regularly and commit often. So it's like do a regular commit. So this is how I'm going to, this is the concept I'm going to use for my for committing. So a regular commit is I do it every day. At the end of my workday, I do a commit. That's regular. The often part is do it more often than daily, right? So, and I like the concept of committing anything that I would never want to lose. So if I have made major progress, or I've created a variable that took me a whole lot of research on the internet to figure out how to do it, I'm going to commit that so that I don't lose it, right? So I'm going to check out feature 1 again. So here I am. So how do I get this into the main branch of code, right? So we look at our Git log. Here's our master branch. I'm going to git merge master. And it's saying it's already up to date because there's a reason for that. I really wanted to check out master. And then I'm going to git merge feature 1. Oh, before I do that, let's do an ls. So see, there's nothing here in this directory. If I do a git merge feature 1, if I do an ls now, ta-da, there are the files that are in feature 1, right? So everything that's in feature 1 is now in master. And if I do a git slog, you'll notice that master now is in the same place as feature 1. Feature 2 has not moved. It's still back there on that initial commit. Now, come on. I've got this other repository, right? And if we do an ls in here, do a git slog, this repository exists. So what I'm going to do, is I'm going to go up a level here, and I'm going to git clone git _ demo, and I'm going to say git _ I'm going to call it clone. So now if I go into git _ clone and do a git slog, check it out. If I go here and I go into that, if I go GitHub, and this is just a directory on my device that has all my GitHub repositories, and I go into Git Demo and I do a git slog here, you'll notice they're exactly the same. Except for the fact that over here, we've got this concept of origin. Now, if I'm over in my origin directory and I say git touch, here I'm going to use this create function that I've got. So I've got create and 1, 2, 3, 4. Oops. That's right. Okay. All right, I'm just going to touch some files for A in 1, 2, 3, 4. Do touch A. Done. Now, if I look here, I've created these files 1, 2, 3, 4. Git status. Those files exist, so I'm going to git add dot git status now. They're all now part of the staging, so I'm going to git commit. minus AM, adding files. So now this is, now if I look here, my git log. So here I am, I'm in my local directory, right? On feature 1. And this SHA is adding a whole bunch of files to feature 1. So now over here, I'm going to do something. I'm going to do something similar. Let's say for A in A, B, C. Do touch $A.text. Done. And I look here. I'm on Git status. I'm in feature 1. I'm going to change my branch because I just don't want to have that nightmare in this demo. So git checkout -B testing. And now we're going to git add dot and git commit -AM, adding on remote. Okay, so here we are, git log. So here's my testing branch, adding on remote. If I go over here and I go to git log, you notice that that doesn't exist yet. But if I do a git fetch, what this does is it pulls the history. So now I know that testing exists, right? But you'll notice that origin testing exists, but I don't have the testing branch locally. I'm going to put a pin in that. So here I am on feature 1. So now I'm going to do a git push. So now if we look at git log, now you notice that origin feature 1 is here. If we look here, origin feature 1 is not. But if we do a git log now, here we are, feature 1. We've done this adding file branch or commit. You'll notice this commit is the same number, the same SHA. So now that is here now. So we've pushed our changes to the remote, and we've pulled the changes from the remote. Now, if I do a git checkout testing and git log, now I have the testing branch locally. So demonstrated git pushing and pulling, the concept of fetch. So fetch pulls the history, but it doesn't pull the files. The only time when you pull the files is, excuse me. If I go back here to testing and I do this same thing that I did here, but I do D and E, and then I commit that, I get add those guys, and I get commit those guys. Just adding more on the remote, and we do a git log. So here, if I do a git status, it's going to tell me, hey, oh, if I do a git fetch, it's going to say, hey, I'm behind by 1 commit. So if I do a git pull, so if I do an ls before I do that, you'll notice that I don't have D and E. If I do a git pull, I do. If I do ls now, there's D and E, right? So git pull, git push, git fetch. We've talked about git merge. There's a concept called git rebase. And what git rebase allows me to do is, and we're running out of time here, and I don't want to take more time than people have committed themselves to. It allows me to actually move my code. So if we do our git log, and I guess I'll demonstrate this. This would be pretty quick. So say I want feature 1 to actually come off of this testing branch. I can move that code. So first thing I need, when I want to do that, the first thing I'll do is I'll do a git merge merge base. And I'm going to do that from my head, because I'm standing on my head, and feature one. And so this SHA, what it's saying is this SHA is their common ancestor. So this is where their common ancestry is. So I'm going to get rebase onto actually, I'm going to get checkout feature one first. And then I'm going to get rebase onto testing. Going back to here, so copy that, paste that there. And we're going to call it feature one. I want to keep the name that I'm using on this branch. Oops. And if I do a git slog now, I've moved all my code that was on feature one, and it's now on top of testing. So if I do an ls, I'm going to have A, B, C, D, E, and F in here, or A, B, C, D, and E in here, as well as the 1, 2, 3, 4 that I created in feature one. Now, when you do a merge and you do a rebase, there's a good chance, if you're working in a multi-developer environment on common code, there's a reasonable chance that you're going to have conflicts. And that's one of the things that Git does, is it allows you to resolve those conflicts. I'm not going to demonstrate a conflict just because that gets pretty heady. Something to know is there's this concept of a tilde. So if we do a git slog, here's my head. If I say git checkout head tilde 2, that's going to pull my head back 2 commits. And it's going to warn me, oops, that I misspelled checkout. If I look at my git slog now, it's warning me that I'm in a detached head because there's no branch at that location, but I moved my head back 2 commits. Now, why would I want to do that? Why would I want to know that? So here's an example. If I do git checkout, if I go back and check out feature one. So here I am at feature one, and ooh, I didn't really want to do that rebase at that pointer. I didn't want it here. I wanted it actually at this commit. If I do a git, or more to the point, so if I do a git reset -- hard head tilde tilde, my head now and feature one is 2 commits back, right? If I do my git status, tells me where I am. If I do a ls in my directory, oh wait, oh, where did my 1, 2, 3, 4 go? Oh shoot. Okay, so I'm demonstrating here what can happen, right? So, oh geez, what happened? Where did my files go? I'll tell you where they are. I've got this SHA right here. If I go and check out this SHA. Oops, that's not the SHA I wanted. I wanted the SHA here. Git checkout. It's going to tell me I'm in a detached head, but check it out. There's my files. Git means never having to say sorry. There's some other concepts in here. Just because we're running out of time, they'll be in the presentation. Feel free to reach out to me. There's concepts on Rebase Interactive, which allows you to reset your history, write your history, the creation of a git ignore file, which means these are the types of files I don't want in my file. Removing files from your history, but not from your directory, that sort of thing. But at that, I will leave it. I will go take questions.
Wow.
Questions.
Well, first of all,
Fantastic. Yeah.
thank you. Yeah, it was very good. I have a question. So if you're in a state where you have detached head,
Yes.
how you reattach it?
So you just create a branch. So here here we are, right? So here I am, I'm in a detached head, right? If I do a git branch, minus, so you'll notice you can either do it with this command, so we can go a git switch. So git switch. I don't use this command very often, but git switch -c and feature 3 or feature 3. Now, if we look at slog, here I am. I'm no longer in a detached head, and there's my files.
Okay.
Yep. A great question. And one of the things to note too, sometimes you can get yourself in a detached head that's invisible in slog. And if it says you're in a detached head and you do a git slog and you don't see your head, make a branch right then and there, create a branch, because then you'll know where you are.
Okay. About what you said that commit often, also when you have a team and many people commit often, what you want to do, you actually want to check what they have committed. So I usually end up, like if several repositories, creating a small script, which I can just run with one command, and it will either fetch or pull all these changes, and I see if something new happened, and if there is any conflict, I see it right away.
Yep.
Do it at
And
least
one of the
once a
things,
day.
this is the ability to rewrite your history, because here you are, you're writing your code and you went, oh geez, I misspelled the variable name in one spot, and you got to go fix that variable name. You don't want to commit that as part of the public history. Git Rebase Interactive allows you to go back in and squash that commit. It still happens in the document history, but it's not in the Git messages. So nobody knows that you're poor at spelling.
Okay. Yeah. Any more questions? Hello? Okay.
If somebody is speaking, Oleg, you're on mute.
I am sorry. Yes, I was on mute. Is any GUI for Git? I mean, amount of commands you used, right, is tremendous, and it's like even more. There is a Git stash and so on, right? Is anything that can simplify working with Git, basically?
Yeah, there are a lot of GUIs. I have not found, to me, frankly, picking up my mouse and doing something with my mouse breaks my workflow. Not sure if I have. Yeah, I've got GitHub Desktop installed. So GitHub Desktop allows you to do a lot of this stuff. A lot of IDEs like Visual Studio Code and PyCharm, they've got the commands built into them, that sort of as well. So they're easy to. So if we go back and this is not where I want to be. I think I can open a local repository. So if we go and choose this repository, so here's our demo repository. There's no local changes, but here now, oops, let's go back to that. We can see the changes. We can create a branch from here. You can cherry pick. You can do a lot of the things I did in the command line from the GUI in this interface, for example. But honestly, I feel it's way more efficient to operate from the command line because I know what I'm doing. Here, I'm letting the GUI decide what I'm doing.
In our company, we're using GitHub, And as I found more for me more efficient to use GUID actually. It's a Visual Studio. We have Visual and Visual Studio Code. There is a plugins.
Yes.
And actually there is a web version, right? Web version of GitHub, which is very convenient to use as well. Yeah, but sometimes there is some glitches. So of course, if we need to fix something, so whatever you explain, it's exactly what we are doing. We are going to terminal and fixing through command. Yeah, so definitely it's very nice to understand what is behind this, what is the structure. So fantastic lecture. Thank you so much for this.
Sure.
Yeah, but for GUID, yes, we our company we prepare more GUID.
Yeah, and frankly, conflict resolution, I always use a different. I don't use the command line because there's vimdiff. I never understand what it's doing. So I have a tool that I use for merge conflicts because then I understand exactly what I'm doing.
Of course, yes. Yeah, web version fantastically also done, very convenient. So you can see history, you can merge, you can. So yeah, but it takes a little bit time to learn.
Yes.
Yeah. Chris, I want to say from my experience, I started with command line, then I tried different GUIs. The last one I used was called Tower, which is used by professionals. It's a paid software and it allows you to have multiple accounts. But then recently what's happening, different accounts, different logins are not really needed if everybody's using GitHub because they just invite your user. So you're basically using one user. But anyway, I still return to the prompt. It just somehow I can script my regular activity. I just make very simple shortcuts and I'm faster when I'm on the prompt.
Yes, that's exactly my opinion too.
Right. Yep. Thank you very much. It was great lecture.
That's really great. Yes.
Yeah. Thank you.
There'll have to be like an intermediate Git with like Rebase Interactive and things like that. So.
Okay, I'm stopping the recording.